Hello friends, welcome back. In this video, we will discuss the various packet types that we use with ISIS routing protocol. However, before we go ahead and discuss the packet types in ISIS, let's discuss a very important point that we touched upon in our introductory video, where we said that ISIS packets are encapsulated at layer 2. Hence, ISIS is regarded as a layer 2 routing protocol, not a layer 3 routing protocol like OSPF, EIGRP, RIP, etc. So when we say ISIS is a layer 2 routing protocol, why do we say that? Let's have a quick discussion on that using packet capture so you get a real feel of how encapsulation looks like with ISIS. Also, we will do a comparison of the same with an OSPF encapsulated packet so that we can do a real-time show and tell. So friends, this is the topology that we will be using that you see on your screen. So we have routers R1, R2, and R3. They are in ISIS area 49.0123, and then we have R4 and R5 in ISIS area 49.0045, and we also have a couple of routers in OSPF. So R6 and R7 are in area 0. We have added these routers to do the comparison like we mentioned earlier. So let's jump right into it. So we configured R1 with area ID 49.0123 and a system ID of 1000.0000.0001. Similarly, we configured R2 with the same area ID of 49.0123. However, as the system ID needs to be unique, the system ID in case of R2 ends with 02 as compared to 01 with R1, and the end cell or network selector is 00, and we will discuss the breakdown of NET address in ISIS in future videos. So we have L1, L2 peering or adjacency between R1 and R2, and let's have a quick look at a packet capture between R1 and R2, and more specifically we are looking for ISIS packet exchange. So here we have a Wireshark packet capture of an ISIS hello between R1 and R2. So we see the ISIS hello message. So the circuit type is the default of level 1 and level 2. The system ID is the system ID of R1 that we configured using the command NET on R1, and it also carries the adjacency state between the two routers, and currently the adjacency state is up like we see on the screen, and we have the IP address of the sending interface, which is 10.1.2.1, which is the gig01 interface on R1 like we checked on our topology earlier. So now if we look at the encapsulation of ISIS hello message, this is encapsulated inside the common ISIS header that goes for all the ISIS packets, and then it is encapsulated inside Ethernet. So like we see here, the source is the MAC address of the sending interface, which in our case is gig01 on R1. So let's verify that. So like we see, the MAC address of interface gig01 on R1 is this value here, and that's what we see as the source interface. So that's the standard Ethernet logic, and the destination MAC address we see here is the default MAC address used on a point-to-point hello. So going forward, we'll also discuss the various packet types that are used in ISIS routing protocol, and one of the values that we need to consider or remember is the MAC address that is used on a point-to-point hello. So this is the value that is used as the destination MAC address on a point-to-point hello. And if we look at this capture carefully, we will see that we have the Ethernet header, but we do not have an IP header. So like we see, ISIS hello message encapsulated within the common ISIS header, and that gets encapsulated within Ethernet header. It does not have an IP header. And like we discussed earlier, we have configured routers R6 and R7 in OSPF area 0. So we have the neighborship up between R6 and R7 like we see on the screen. So now we will do a packet capture on the interface connecting R6 and R7. So like we see on the screen, we have an OSPF hello packet sent by router R6. Like we see, this is a standard hello packet encapsulated inside an OSPF header. So that's the OSPF source router. That's the router ID of R6. And it is encapsulated inside an IP packet, like we see here. And we see the source as 10.6.7.6. That's the interface IP address that we configured on R6 interface gig 01. It has a protocol ID of 89, which is the protocol number for OSPF, and we see the destination IP address as 224.0.0.5. That's the multicast address that is used for OSPF, and then the IP packet gets encapsulated inside an Ethernet frame. So the source MAC address is the interface MAC address for gig 0 on R1, like we see 0CAD62830001, and that's the MAC address that we see on the interface gig 01 of R1. And we also see the destination MAC address. This is the multicast MAC address used to send point-to-point hellos on a point-to-point interface running OSPF. So friends, I hope that you now get the differentiation between an OSPF packet as compared to an ISIS packet. So now we should be clear when we say that ISIS is a layer 2 protocol as compared to OSPF, which is a layer 3 protocol. We discussed why ISIS is considered as a layer 2 protocol as compared to OSPF, which is a layer 3 routing protocol. And that's because of the encapsulation, which we verified with packet captures. So friends, let's now discuss the various packet types that we use with ISIS. So there are 4 types of packets that we use with ISIS routing protocol. The first type of packet is called the ISIS hello packet, or IIH. So the function of ISIS hello PDUs, or IIH, is very similar to hello messages in OSPF. So it is used to discover neighbors and to maintain the adjacency. And these hello PDUs can be divided into 3 types. The first being the ES to IS, that is sent from an end station to IS, or router in IP terms. The second type being IHH, which is the hello messages sent from an IS or a router to ES, or end station. And the third type being the IIH, or IS to IS hello PDUs. So these are the hello messages sent between 2 routers running ISIS, and the interval of these messages is 10 seconds, and the dead interval is 30 seconds. And unlike OSPF, these timers do not need to match on 2 routers running ISIS, so they can be configured with different values and they can still become neighbors. And on a multi-access network, we use the IIH PDUs, or IS to IS hello messages, to elect a DIS, or a designated intermediate system. And a DIS in ISIS is analogous to a DR in OSPF. So like the way we elect a designated router in OSPF, similarly we elect a designated intermediate system in ISIS. And this is to reduce the number of adjacencies in a multi-access network. So instead of having each router to maintain or to establish neighborship with all the routers in a multi-access network, the routers they only maintain peering or neighborship with the DIS, and the protocol exchange is performed via the designated IS. And unlike OSPF, in ISIS there is no backup designated IS. So we have a DIS and there is no backup for it in ISIS. And also in ISIS, the DIS is preemptive. So if the DIS goes down for some reason and then when it comes back up, the original DIS reobserves the role of the DIS, which is not the case with OSPF, where DR and BDR roles are non-preemptive. The second packet type that we have in ISIS are the LSPs, or the link state PDUs. So the link state PDUs are the packet types that are used to carry the routing and topology information. So every router in an ISIS area or ISIS level generates its own LSPs to describe its local links and reachable subnets. And LSPs in ISIS are analogous to LSAs in OSPF. So in OSPF, we exchange the LSAs to update all our adjacent routers of the topology information. So the routers in OSPF, they exchange LSAs to make sure that all the routers in a common area have the same view of the topology. Likewise, in ISIS, the routers running ISIS, they exchange LSPs to make sure that they have the same view of the topology for that level. The next packet type that we exchange in ISIS are the partial sequence number PDUs, or PSNPs. PSNPs are sent when there is a missing information. So with PSNP, the missing information is requested and acknowledged when the missing information is received from the neighbor. So we can compare PSNPs to link state requests and link state acknowledgements in OSPF. So like in OSPF, we request missing LSAs using link state requests and acknowledge them by sending link state acknowledgements, or LSACs. Similarly, in ISIS, we request and acknowledge link state PDUs using partial sequence number PDUs, or PSNPs. And last but not the least, we have complete sequence number PDUs, or CSNPs. They are exchanged at the beginning or at the router initialization, and they can be compared with database description packets in OSPF, and they are used to synchronize the link state database. For point-to-point networks in ISIS, both the routers can send CSNPs. However, on a multi-access network or a broadcast network, only the designated intermediate system sends these CSNPs, and they are sent every 10 seconds on a multi-access or broadcast network, as compared to point-to-point, where they're only sent at the beginning or at the initial phase of the adjacency. And now we will go to our topology and analyze the various ISIS packet types, so we have a better understanding of the various ISIS packet types. So here we have a packet capture of an ISIS hello message sent by R2. So let's have a look at the various important fields of the ISIS hello message. So we have this system ID of the sender, which is the one ending with 002. That's what we assigned to router R2. We have the PDU length, which is 1496. In bytes, we have the local circuit ID with a value of 0. We can also verify the local circuit ID on the CLI. So let's take a quick look. So we see that the interface kick01 on R2 is running both level 1 and level 2. So that's what we can confirm here from the circuit type. And it has an interface number of 00 like we see on the screen, which is the local circuit ID here. And it has discovered the neighbor system ID as R1, and we see the point-to-point adjacency state as up, and we also see the protocol supported field, which supports an LP ID of 0xCC, which stands for IP. So NLP stands for Network Layer Protocol ID, and 0xCC identifies IP at the network layer. It also carries the area address information like we see on the screen, and the IP address information of the interface from where it's sending the ISIS hello, and it also has the padding values to make up a standard ISIS hello message. So that's how an ISIS hello message looks like. So let's now take a look at an ISIS LSP sent by R2. So here we have the ISIS packet type. So in this case, it's an ISIS link state PDU or ISIS LSP that is encapsulated inside the common ISIS header, like we discussed earlier. So any ISIS packet, be it a hello message, LSP, CSNP, or PSNP, will be encapsulated inside a common ISIS header. So here we have the LSP ID of R2, and we see the various fields here, the most important being, or one of the more important fields here being the attached bit. So we will discuss about attached bit and its function going forward when we discuss the various levels used in ISIS routing protocol, and also how a level 1, level 2 router advertises a default route to a router running level 1 routing. And like we see, the attached bit currently is not set. We have the overload bit, which is used when the router is overloaded, or more specifically, we use this configuration during maintenance when we want other routers to not use this particular router as a transit router. And then we have the area address field, which contains the information regarding the area ID, like we see here, 49.0123. That's the area we configured on router R2. Then we have the protocol supported. So in this case, it's 0xCC, which, like we discussed earlier, stands for IP. Then we have the host name of R2. Then it also has the IS neighbor field that it has discovered on that link. In this case, it's R1. Then we have the interface IP of the sending interface. And then we have the topology information from this particular router. So router 2, so it's telling router 1 that, hey router 1, I'm aware of these prefixes. So it knows about 10.1.2.0. It also knows about 10.2.3.0/24, and then it knows about 10.0.0.1. So this is how LSPs are sent in ISIS. And to ensure database synchronization, a router will flood its own LSPs every 15 minutes by default. So that's the default timer used for LSPs in ISIS. So let's have a quick look at the ISIS PSNP or partial sequence number PDUs. So like we see on the screen, the source ID is the R1, as we see the system ID ending with 0001. The most important information that's carried inside the PSNP is the sequence number, and that's how routers know whether their LSP in their link state database is updated or not. For example, if the router receives an LSP where the sequence number is newer, it will send the PSNP to request for new information, and when it receives the new information from the neighbor, it will again send another PSNP to acknowledge the receipt of that missing information. And last but not the least, let's take a quick look at the CSNP packet capture. So here we have a CSNP sent by R1. So we see the source ID of R1 with a value ending with 0001, and then the important piece of information that is carried inside a CSNP packet are the LSP sequence numbers, the lifetime, the checksums, and the LSP ID of the sending router. And this carries a summary of the LSPs on that particular router. And like we discussed earlier, CSNP is analogous to a link state database descriptor packet in OSPF, where we exchange a summary of the link state database. And on our topology, we adjusted the interface type to run point-to-point network type for ISIS. So if we do a show run interface gig 01, we see that we changed the ISIS network to point-to-point, where the default is broadcast or a multi-access network. So if you remove the ISIS network point-to-point command from the interface, and let's now verify the interface type on gig 01. So it still says circuit type is level 1.2. It's now electing a DR, which means it is a broadcast network type. So let's check the interface type on gig 01 on R2. We see no mention of a DR election here because it is currently configured as a point-to-point network type. So let's verify that. Show run interface gig 01. So like we see, it is an ISIS network of point-to-point, and hence we have lost the neighborship between R1 and R2 because network type is a field that must match on both the routers to become adjacent. So now if we change the network type on R2 gig 01, so let's do a no ISIS network point to point. And now if we do a show CLNS interface gig 01 on R2, we see that it is now performing a DR election, and the DR election goes based on the priority on that interface. The default priority is 64, and if both the interfaces are configured with the default priority of 64, then the MAC address becomes the tiebreaker. So if we do a show ISIS neighbor now, we see that the neighborship has come up. It has established two adjacencies, L1 and L2, because the default IS type in ISIS is level 1.2. So let's verify the same on R2, and like we see, the adjacency has come up and the DR on this interface is R2. And now we see that the CSNPs are sent every 10 seconds on broadcast network type, and it's only the DIS that's sending the CSNP on the broadcast network type. This is one of the differences between broadcast and point-to-point network type in ISIS. And also, for the purpose of optimization, it is a common practice by administrators to change the IS type to only level 1 or level 2 instead of running both levels 1 and 2 on the router, which we will discuss in upcoming videos. So friends, this was a detailed overview of the various packet types that we use in ISIS routing protocol, and also we discussed why ISIS is considered as a layer 2 protocol as compared to OSPF, which is a layer 3 routing protocol, and that's because of the encapsulation, which we verified with packet captures. So friends, I hope you liked the video, and if you did like the content, please give it a thumbs up. Also, please share it with your friends and colleagues, and you can also support the channel via Buy Me a Coffee. The link is in the description. So friends, that's it for this video. Thank you very much for your time today, and I will see you in the upcoming videos.